The luxury train slows. The final stop approaches. But one passenger is missing. Ticket scans show a gap. Dining car logs whisper secrets. Sleeper cabin doors tell a strange story. Someone left before dawn. Who vanished into the night? Join me. We will uncover the truth together.
Hi, welcome to this crime case. Let's solve this mystery together. We have a missing person, a midnight train, and a handful of clues. Are you ready to investigate? Let's dive in and see what the evidence tells us. First, we need to gather our evidence. We'll look at 3 key datasets: ticket scans, dining reservations, and sleeper cabin door logs. Each one could hold a vital clue. Let's see what secrets they reveal about that mysterious night. First things first, we need our toolkit. By typing import pandas as PD, we're bringing in a powerful Python library called Pandas. Now let's pull up our first piece of evidence. Here, we're creating a variable called ticket_scans and setting it equal to pd.read_CSV. That's Pandas' way of reading a file full of ticket scan records. We're telling Python to open the file called datasets/ticket_scans.csv. This variable will hold all the information about who scanned their ticket and when. Perfect for tracking everyone who boarded the scene of the crime. Next, we need to know who dined where and when. We're making another variable, dining_reservations, and loading in the dining_reservations.csv file. Again, we're using Pandas read_CSV function. This will give us a table of all the dinner bookings so we can see who might have been sitting together or who had an alibi during the time of the incident. Finally, let's check the sleeper cabins. Here, we're creating a variable called sleeper_cabin_logs and loading in the sleeper_cabin_logs.csv file. This log will show us who entered or left each cabin, crucial for piecing together movements on the night of the crime. With all 3 datasets loaded, we're ready to start connecting the dots. Now, let's take a first look at our data. We'll peek at the top rows of each dataset. This helps us get familiar with the names, times, and possible suspects. Every detail could matter. First up, let's print out the ticket scans. I'm typing print, open parenthesis, single quote, ticket scans, single quote, close parenthesis. This command tells Python to display the words ticket scans on the screen. It's like labeling our evidence table before we lay out the clues. Now let's actually see the data. I'm typing print, open parenthesis, ticket_scans, close parenthesis. Here, ticket_scans is a variable. Think of it as a box where we've stored all the records of who scanned their ticket. By printing it, we're revealing the list of everyone who boarded the train. Let's see if anyone stands out. Next, I want to check the dining reservations. So I'm typing print, open parenthesis, \n, dining reservations, close parenthesis. That \n is a special character in Python. It creates a new line so our output doesn't get messy. We're basically saying, let's start a fresh section for the dining clues. Time to see who booked a table. I'm typing print, open parenthesis, dining_reservations, close parenthesis. Here, dining_reservations is another variable. It holds all the names and times for dinner bookings. By printing it, we're laying out the guest list for the dining car. Maybe someone had a late night snack or an alibi. Let's move on to the sleeper cabins. I'm typing print, open parenthesis, \n, sleeper cabin logs, close parenthesis. Again, that \n gives us a clean break in our output. We're about to dive into the logs for who entered and exited the cabins, a crucial piece of the puzzle. Finally, let's reveal the sleeper cabin logs themselves. I'm typing print, open parenthesis, sleeper underline cabin underline logs, close parenthesis. This variable holds all the comings and goings from the cabins. By printing it, we're opening the door to possible late night movements, and maybe, just maybe, a clue to the crime. Look closely at these first clues. All passengers scanned in at Central City at 9 p.m., but there's a strange scan at 3:20 a.m. at Riverside by someone called Unknown. Most people went to dinner except Olga Petrov, and Dr. Hart's cabin door opened at 3:12 a.m., just before that mysterious scan. Let's dig deeper into the timing. To solve this, we need to analyze the timeline. We'll convert the time columns to real date and time values. This makes it easier to compare events and spot suspicious activity. First things first, I'm importing the datetime module. Think of this as grabbing a toolkit that lets us work with dates and times in Python. We'll need this to piece together our timeline of the night's events. Every minute could be a clue. Now I'm taking the scan time column from our ticket scans data and converting it into a proper datetime format using Pandas. In plain English, I'm teaching Python to read those times as actual clock times, not just plain text. This way, we can line up exactly when each ticket was scanned and spot if anyone slipped in or out at an odd hour. Next up, I'm doing the same thing for the sleeper underline cabin underline logs. I'm converting the door truck open time column into a datetime object. This lets us track precisely when each cabin door was opened. If someone snuck out of their room when they shouldn't have, this is where we'll catch them. And finally, I'm converting the dinner time in our dining underline reservations to datetime as well. By lining up everyone's dinner reservations, we can see who was in the dining car and who had an alibi at the critical moment. Every timestamp is a potential piece of the puzzle. Now, let's see who opened their cabin door during the night. We'll focus on doors opened between midnight and 4 a.m. This could reveal who was moving around when Dr. Hart disappeared. All right, let's get to work. I'm creating a new variable called night underline logs. In Python, a variable is just a name we give to a piece of information we want to keep track of. Here, I'm using it to store a filtered version of our sleeper underline cabin underline logs. That's our big list of everyone who opened the cabin door. I'm telling Python to look at the door underline open underline time column and check the hour for each entry. If the hour is greater than or equal to 0 and less than 4, so between midnight and 4 a.m., we keep that record. This way, we're zeroing in on any late night activity when most people should be asleep. Let's see who was up to something after dark. Now, I'm just typing night underline logs on its own. In Python, when you type a variable name like this, it'll show you what's inside. So we're about to reveal a list of all the door openings that happened in the dead of night. Let's take a look at who was moving around when they shouldn't have been. Here's what we find. Only Dr. Evelyn Hart's cabin, A1, was opened during the night at 3:12 a.m. That's just 8 minutes before the mysterious ticket scan at Riverside. The timing is almost too perfect. Now, let's compare the door logs and ticket scans. Could anyone else have left the train at 3:20 a.m.? We'll check if any other doors opened before that Riverside scan. This is where things get interesting. Let's start by setting our sights on a key detail. We want to find all the doors that were opened before 3:20 in the morning. That's our first clue, and it might just lead us closer to the truth. Here, I'm creating a variable called cutoff underline time. In Python, a variable is just a name we give to a piece of information we want to remember. I'm using Pandas to underline datetime function to turn the string 0320 into an actual time object that Python can understand and compare. This way, we can check which doors were opened before this exact moment. Now, let's dig into the sleeper underline cabin underline logs. I'm filtering this data frame, which is basically a fancy table of all our door activity, to find only the rows where the door underline open underline time happened before or exactly at our cutoff underline time. This filtered list, which I'm calling early underline doors, will show us every door that was opened before 3:20. In Python, this kind of filtering is called Boolean indexing. We're asking for each row, is the door open time less than or equal to our cutoff? If yes, keep it. If not, toss it aside. Let's take a look at early underline doors. This will show us the exact records, the who, the when, and maybe even the how for every door that was opened before our suspicious time. What secrets will these early entries reveal? Once again, only Dr. Hart's door was opened before the Riverside scan. The other passengers' doors opened much later in the morning, except for Olga Petrov, whose door opened at 22:30 the night before. The window of opportunity is very narrow. Let's check who attended dinner. Skipping dinner could mean someone was planning something or hiding. We'll see if anyone's absence gives us a clue. Let's start digging into the dinner records. Here, I'm creating a new variable called skipped underline dinner. In Python, a variable is just a name we give to a piece of information we want to keep track of. So, skipped underline dinner will hold a filtered list from our dining underline reservations data. I'm telling Python, show me only the reservations where the attended column says no. Basically, we're pulling out everyone who was supposed to be at dinner but didn't show up. Could one of these absences be our first clue? Now let's shine a light on what we've found. I'm using the print function. Think of it as asking Python to reveal what's inside our skipped underline dinner variable. This way, we can see the list of guests who missed dinner right here in front of us. Every name here could be a potential lead. Let's see who's missing from the table. Only Olga Petrov skipped dinner, but her cabin door opened much earlier, at 22:30. The rest, including Dr. Hart, all attended dinner. So, skipping dinner doesn't seem to connect directly to the disappearance. Now, let's visualize the timeline. We'll plot the key events to see the sequence of actions during the night. Sometimes, a picture reveals what numbers can't. First things first, I'm importing matplotlib.pyplot as PLT. Think of this as grabbing my detective's toolkit for visual clues. PyPlot lets us create all sorts of charts and timelines so we can actually see the story our data is telling. Now I'm setting up the canvas for our investigation with fig ax equals plt.subplots, and I'm making it 8 by 4 inches. In Python, fig is short for figure, and ax is our set of axes, basically the blank page where we'll plot every suspicious movement. Alright, let's make a note. We're about to plot the door open times. This is where we'll see exactly when each cabin door was opened during the night. Could be a key clue. Here's where we get hands-on. I'm looping through each row in sleeper underline cabin underline logs using iteros. That's Python's way of letting us examine every single entry one by one. For each row, we're plotting a blue dot at the door underline open underline time for that passenger. The first dot gets a label, so we know what we're looking at. This will help us spot any unusual midnight wanderings. Now let's switch gears. We're about to plot the ticket scans. This will show us when each passenger's ticket was checked. Maybe someone tried to sneak in or out. Again, we're looping through each row, but this time in ticket underline scans. For each scan, we're checking if the passenger is listed as unknown. If so, we mark it red, a possible intruder. Otherwise, it's green for a known guest. We use a little X marker for these, and the first one gets a label. This way, we can instantly spot any suspicious scans. Now, I'm drawing a vertical purple dashed line at exactly 03:12 a.m. That's when Dr. Hart's door was opened. In Python, ax.axline lets us highlight a specific moment in time. This could be a turning point in our timeline. Next, another vertical line. This one's orange and marks 03:20 a.m. when a ticket was scanned at Riverside. Again, ax.axline helps us spotlight this event. We'll see if these two moments connect. Let's label our x-axis as time. In Python, ax.set underline x label makes it clear what we're looking at along the bottom. Every tick is a moment in our investigation. And now the y-axis gets its label, passenger. That's ax.set underline y label. This way we know who's involved at each point in time. Every dot or x will line up with a name. Time for a title. Ax.set underline title gives our chart a headline, timeline of door opens, and ticket scans. This sums up exactly what we're investigating, so anyone glancing at our chart knows what's at stake. Let's add a legend with ax.legend. This is like a key to our map. It explains what each color and marker means, so we don't miss any clues. I'm calling plt.tight underline layout to tidy things up. This makes sure our labels and lines don't overlap, so every detail is crystal clear. In Python, it's like straightening up the evidence board before we present our findings. Finally, plt.show brings our timeline to life. The chart pops up, and now we can see the whole night unfold. Every door opened, every ticket scanned. The clues are all here, waiting for us to connect the dots. Here's what we've uncovered. Dr. Hart's cabin door opened at 3:12 a.m. The only door opened during the night. A ticket was scanned at Riverside at 3:20 a.m. by unknown. No other passenger's door opened before this scan. Olga Petrov skipped dinner, but her door opened much earlier. So it looks like Dr. Hart, or someone using her ticket, left the train at Riverside in the dead of night. Was it really Dr. Hart, or did someone else take her place? The evidence points to her as the only one who could have exited at that time. You've pieced together the crucial timeline and cracked the case. Well done, detective.